Mr. Heffernan here, and here's a short example of how to draw a ray diagram for a plane mirror and how to find the location of an image in a plane mirror. From personal experience, though, we all know that if you look at a mirror and you blink your right eye, so like blink your right eye, then your left eye will blink in the mirror. And we also know that if you look in a mirror, you appear to be the same distance from the mirror, like your image appears to be just as far away from the mirror as you do from the mirror. So you should get the same distance. How do we do that with ray diagrams? So we need 4 rays, 2 from the head and 2 from the bottom. So first thing I'm going to do is I'm going to draw a ray from the top of the head towards the mirror like this. Now, according to the law of reflection, when the ray hits the mirror like that, it should reflect at the same angle. So if I just measure the angle right here, there we go, I can see that it's coming in at about an 8-degree angle with my protractor. And so if I was to rotate my protractor around, that means I need to make a reflective ray that comes off the mirror at also a right angle. An 8-degree angle. So I'm just gonna rotate my thing around here. Here we go. Okay, and just flip that as well. There we go. Oops. There we go. So there's my reflective ray right there. So it's coming. So here's the angle of incidence, 8 degrees, and it's coming off at 8 degrees. Now what you want to do now is draw an extension line for your reflected ray. So to basically just extend the line behind the mirror. And to show that it's an extension line, a good thing you can do is maybe turn it into a dashed line like this. There we go. So I got one ray done. So this incident ray hits the mirror, bounces off at the same angle, and then we draw the extended line. Okay, so now we're just going to do another ray, but this time we're going to have the ray come up at a different angle, and it's a little easier if it goes in the opposite direction. So there we go. So this ray is going to go like right here. There we go. Okay. So we need the reflected ray as well. So I'm going to go back and grab my protractor here. Okay. So the angle of incidence, if I measure the angle there, this ray was coming in at, it looks like, oh sorry, go back down to where the ray is. There we go. It looks like, yeah, it looks like it was coming in at about a 10-degree angle. And so we want to reflect at about a 10-degree angle. So I'm just going to grab my ray here. There we go. And it's going to reflect at a 10-degree angle. So whatever your angle of incidence is, that's the angle of reflection. So as you can see, it comes in at a 10-degree angle and it comes off at a 10-degree angle. So all I got to do now is just draw the extension line for that one. So I'm just going to draw my extension line, and just to make it look a little different, to show that it's like an extension line or imaginary line, I'm just going to change it to be a dashed line. There we go. Okay. All right. As you can see, the 2 dashes intersect right here. So the 2 rays off the head intersect right here. So this is where the head will be for the image right there. Now we just have to do the same thing for the feet. So from the foot, I'm going to draw a ray that comes to the mirror right about here. Okay, I measure that that angle. So I may have to rotate my compass around again. There we go. So I'm just going to measure the crosshair of the protractor there. There we go. So this is coming in at, looks like about a 7-degree angle. It's a lot easier to do in real life. You do it on the computer, it's kind of tricky. And so when I draw the reflected angle, I'll just make a copy of that one there. Okay, it's going to reflect off at the same angle, 7 degrees, like that. So all I got to do now is draw the extension line going back into the mirror like this, and then make a dashed line out of it. So I'm just going to do that right now, make a dashed line. There we go. So now I just need one more ray. I just need another ray coming off the foot. So I'm just going to come off at some angle, like maybe like that. It's got to hit the mirror though, so maybe I'll hit the mirror like right there. So if I check to see what angle that's going to be, I'll just grab my trusty protractor for that. I think they were invented by a farmer because they're protractor. So this is coming in at a 25-degree angle. So, oops, okay. Grab my protractor there. There we go. Move it up to where it hit the mirror. And so I need to come off the mirror at a 25-degree angle as well. So I'm just going to grab that right there. Okay, and there we go. So I'll just move the protractor into the right spot. So as you can see, I came incident at a 25-degree angle. Now I'm coming off at a 25-degree angle. Good. All right, good. So I won't need the protractor anymore. That's done. So I'm going to now draw the extension line. Sorry, my eye was itchy there. Like right there. There we go. And I'm going to turn that into a nice little dash line as well. There we go. Okay, cool. So that's where the feet are going to go for our pack person. So I'm just going to copy this over and bring it over. There we go. Now remember, so when you look in the mirror, you're not upside down in a mirror, but you are right side left. You are laterally inverted, just not vertically inverted. So I'm just going to show that by flipping my object horizontally. There we go. And so this is going to be my image. So I'll just format that. Let's see. I can make it a little less bright. There we go. Just to show that it's an image. I guess that didn't work, but okay. So now, mathematically, I can check to see, when you look at your image in the mirror, you'll notice that you're the same size in the mirror, or almost the same size. So the magnification should be about 1. And your height's about the same. So really, if we take a look at the formula that we use right here, okay, just going to copy and paste it down. So if your object height was 3 centimeters in height, then that is going to be the same for your image height. They have to be the same. They're both going to be 3 centimeters. Okay. Okay, this is only true for plane mirrors. So there we go. So we got that filled in. And the distance, if we take a look at the distance, we were 6 centimeters. Well, you can see the object is also, so the image is 6 centimeters. And the object was 6 centimeters. They're both going to be the same, 6 centimeters. Okay, just ignore the minus sign. It shouldn't be there in this formula here. It just means it's like virtual. Okay, and so then what's the magnification going to be? It doesn't matter which equation we use. 3 divided by 3 is 1. 6 divided by 6 is 1. We're going to have a 1 times magnification, so it's not going to change. It's going to look the same. And there we go. So the math is just like that. Just to double check, here's our 6 centimeter line that we used for the distance before. I'm just going to copy it over. And you can see that, if I just move over, there we go. So we have 6 centimeters again. And if I grab my 3 centimeter line over here and just drag it over here, you'll see that the image is still 3 centimeters. So there you go. So that's how you draw the ray diagram. You need 4 rays altogether, 2 from the head, 2 from the feet. Just make sure that the angle of refraction is the same as the angle of incidence. And then you just draw your extension lines. And wherever the extension lines intersect, that is where your image is going to go. All right, good luck with your mirror work. Bye.